Ah, what a beautiful day outside.
Looks like he got shot. Should probably take him to the hospital. So, doctor, what do you think happened here?
Oh, officer, this was no shooting. This was a murder. A murder based on vision.
Light travels into the eye through the cornea. It is bent by the cornea and travels into the lens. The lens changes shape depending on an object's distance to bring the object's image into focus on the retina. The light hits the retina, triggering photochemical reactions in two types of cells called the rods and cones of the retina. Their signal is sent in a chain reaction from the rods and cones to the bipolar cells, and then to the ganglion cells where axons converge to form the optic nerve which sends information to the occipital lobe. Depending on what you see, different parts of the brain will activate to form a conscious perception. Not only does the eye respond to light, it also responds differently to different frequencies of light. Cones in the eye either react to green, blue, or red light. Different combinations of the cones firing allows us to see the three dimensions of color. The types of cones firing allows us to sense hue. The number of cones firing allows us to sense a color's intensity or brightness. And the ratio of cones firing allows us to sense saturation. After the signal leaves the photoreceptors, it is processed by neurons that function in pairs. Some are shut down by green light and activated by red, and vice versa. The pairs of neurons are said to be green versus red, yellow versus blue, and black versus white. Opponent process theory helps explain the perception of afterimages on colorful objects. Two common ailments of the eye are nearsightedness and farsightedness. Nearsightedness is when images are focused before they hit the retina, and farsightedness is when the images are focused behind the retina. When Moho was exposed to so much light, his eyes did not melt. Instead, Moho's eyes sent such powerful signals to his occipital cortex that his brain could not handle it and it exploded.
I love that sound of the wind in the trees.
I ain't gon' let it get to me, I'm just gon' creep.
This is the ear. It consists of outer, middle and inner regions. Sound exists in the physical world as a wave. The frequency of a wave is derived from the time between a trough of one wave and a trough of another, and it is perceived as pitch. Amplitude is derived from the magnitude of the distance between the crest and trough of the wave. Amplitude is perceived as volume. The ear channels sound waves down a duct known as the ear canal to the eardrum. The eardrum is the beginning of a chain reaction that sends vibrations down the hammer, anvil, and stirrup bone. The stirrup vibrates fluid within the cochlea which stimulate tiny hair-like cells that produce a neurological signal whenever they waver. Those signals travel to the brain where they are perceived as sound. There are two types of hearing loss: conduction and sensorineural. Conduction hearing loss is when the mechanics of the ear are damaged and do not conduct sound well. Sensorineural hearing loss is when the neurons that transmit or receive sound don't function properly and the sound is not perceived by the brain. As you can see, Moho suffered from both types of hearing loss. In fact, when the doctors examined him, there was only ash left where the ear used to be.
School smells so beautiful. What's that smell? Ew. Oh, God.
The second hit and run of the month. This is an atrocity. These kids have no respect for the dead.
Olfaction is the process by which chemicals in the air are converted into perceived odor. When chemicals in the air land into specific receptor proteins that they fit into, attached neurons generate a signal. Depending on which receptor receives a chemical, a different neurological signal is produced. The signals are transported into the olfactory bulb and then the brain, where the messages are converted into perceived smells. Ever notice how smells can provoke your memory in a jiffy? This is because the olfactory bulb associates with the limbic system. The hippocampus and amygdala are responsible for memory and emotion. This is why our good friend Moho died in this tragic accident. His limbic system was overloaded with stimulation from the intense smell and it self-destructed.
Delicious cow.
What's up, Moho?
What's up, bro?
Heroin? These drugs are really killing the youth. Hey, scientist, did you know China had wars over heroin?
It was opium, not heroin. And this is a bottle of poison anyway.
This is Moho's taste bud. Beautiful, isn't it? Moho's taste bud allows him to taste 5 different sensations: bitter, sweet, salty, sour, umami. Some people think that the taste sensations are divided onto different regions of the tongue. This is false. If we were to cut out Moho's tongue, and of course we would never do that, he would still be able to sense all 5 taste sensations. The sense of taste, like the sense of smell, is a chemical sense. Chemicals in the food Moho eats fit into the receptor proteins of the taste buds. Depending on which taste bud the chemicals fit into, a different neurological signal is generated from the neurons that are attached to the taste bud receptor sites. Those different neurological signals are then sent to the brain and perceived as taste. It was not any poison that killed our good friend Moho. Instead, it was the sheer taste of the disgusting beverage. His taste buds sent so much nasty information to his brain at once, that his brain immediately disintegrated.
Soft meat. So cute.
Seems to be a politically motivated murder. It must have been the liberals.
The lobster's right there.
The 3 types of touch receptors are pressure, warmth, cold, and pain. The only identifiable receptors are pressure. The relationship between the other 3 is unknown. Pain can be perceived when the touch nerves are exposed to extreme hot, cold, stretch, vibration, or acceleration. Pain is caused by anything that can disrupt normal function of the body parts. Pain can also be caused by damaged neurons that fire haphazardly. Pain can even be affected by how much attention you give to it. Gate control theory suggests that the spine can control the pain signals bound for the brain by the closing and opening of gates, and that a gate's state is determined by other stimuli. This can help to explain why some people start rubbing their feet in response to a stubbed toe. Unfortunately, no gate control theories could help Moho in his struggle with an aggressive lobster. Moho did not die of blood loss. Instead, his pain signals were so intense that, when converged in the spine, Moho's spine incinerated before the signals even got to his brain, causing death.
Oh, cool. My vestibular sense. This is really cool. Whoa.
Must have got run over. Think you got run over, Doc?
Actually, he just lost his balance and fell off.
The vestibular sense helps people balance. In the inner ear there are reservoirs filled with a viscous fluid. When the head changes orientation or accelerates, The viscous liquid moves within the reservoirs and is sensed by tiny hair-like cells. These cells generate signals which are sent to the brain and used to maintain balance in symphony with the cerebellum. After all that death, poor Moho must have his semicircular canals damaged, and was unable to balance on the edge. I am sure it wasn't a prankster that pushed him or anything.
Oh, I feel my arm, even though I don't see it. This is really cool. My arm!
Oh no, another murder. This time, some type of pimp. His arm must have been chopped off.
Wow, you're actually right.
Nobody worry, Moho's kinesthetic sense will make it so he will still feel his arm if he is in the dark, or it is behind his head. Also, even though Moho lost an entire arm, he will still have a phantom one right where the old one used to be, to keep him company.
So Doc, who do you think the murderer was?
It was him!
Now time for my final kill.